Hello, today I'd like to show you how to use the DAC4 unit with the NVH Analyzer software in case of quick measurement action. This is especially presented for users which have to make very fast measurements. The main topic in this case will be not the analysis function, it will be the recording function of the raw data. So now let's assume you have connected the DAC4 unit to your PC and you have already connected the accelerometer and here the microphone, for example, to channel number 1 and channel number 2. Next, I select here the DAC4 unit and start the application. So the FRF measurement, this is only for impulse hammer or modal hammer measurements. So we use this here, vibration and odor analysis or acoustics. So now we see here, for example, the sampling rate of the device. Let's say we delivered already some kind of prepared template. In this case, I just go here to load and load this file here. So in the template we can see now the sampling rate is set here to 96 kilohertz, and here I adjusted maximum hard disk recording time 600 seconds. So but it can be also, for example, 3600. So in this case we see here that at this high sampling rate we will get 3 files with maximum 2 GB file size. So here is now already everything prepared. So here at the channel number 1 I have here an accelerometer with 1 volt per G sensitivity. And at the channel number 2, there's a MP30 microphone connected. So here, let's assume on the channel number 3, I get a IEPE sensor, something like an impact hammer or another accelerometer. So then I must enable here the current supply and set it here to AC coupling. So if I don't have here the IEPE sensor, then I can switch off this. So means now I can measure from DC up to 40 kilohertz in a range of ±10 volt. So I have here prepared already the sensitivities. This is so far fine. I set here the recording time to 3600 seconds. That's also okay. And just apply. So because we want to record only the raw data, which is crucial for very seldom or rare measurement campaigns. So then in this case there's no need to take care here too much about this analyzing functions. So now I will make this smaller here. So now I like to dedicate the file name. So I can click here with right mouse button and say new. Raw data. So in this directory I make the recording one. So now I start the measurement, and in this case we just see that some data is coming, which is finally very good. So I see that here data is coming, and I see here some FFT, and so on and so on. So now in this case I have here the display template from FRF measurement. I will stop it here now and change the template to the another one. So means I go here to load. So, and I will load this graphic template. So it looks like this. So I prepared also some another masks or graphic displays. So that means I can change here the directory. For example, to display mask 1. Okay, this is now the speed. I don't want to have the speed. Okay, so in this case, I just change it here to acceleration of the channel number 1. So this is now here auto scaled. Okay, let's see. So because this is now kind of calculated signal, I can adjust here this averaging values. Okay. So now I see here that signal is coming. So microphone signal is also here. I prepared now here's a recording file. So this is here recording 1. And now data is coming. now I can start with the record. So now this test can run few minutes or up to one hour, as I prepared in the previous hardware setup. So I adjusted 3600 seconds. So now I just take a signal generator. This is here in this case microphone calibrator. So it delivers 94 dB. So, and we can see here that the signal is coming. So let's assume the test is finalized. Let's assume the test is finalized. I stop here the recording and stop the display. And so the file is here in the download pop-up in this directory. So let's assume it's the next day after the test. I want to analyze the data. So then I start again the software, and the hardware is somewhere else. The Roga Duck 4 is, let's say, in another room or something like that. So in this case, I can click here to Office. So that means in this case, measurement hardware is not necessary. So I open again this one here. So I make here again the smaller display arrangement. So and now I load the data. So here I say load recording. So this is now here. We can see the channel description. So means I have here accelerometer. Here's the MP30 ultrasound microphone. We made the record with 96 kilohertz. And we just continue here. So I leave it this now as it is as first. So and here in the upper window I can see now the channel number 1, the raw data. So here, offline recording, here I can change to channel number 2. So that means here in this upper line, I will see the waveform signal from channel number 2. So, and here the behavior regarding display is again same. I choose here the display and load another mask. Let's see this one. So I have here time domain level acceleration. Of course, you can change here also any another function. So now I can start the playback. Now we see the recording. in this case the playback. So let's go to the setup, to Analyzer Setup. I will load here the prepared analysis function, so you can see that here many functions enabled. So I want to see here in this window the signal auto-scaled, the y-axis. So now. So this is now here the playback. So I can speed up the playback if I change it here, for example, to smaller overlap. So then the playback speed is now here faster. Or even 0.1 should work, I think. Yeah. So this is a very important and crucial function to store is first the raw data, and after the experiment I have much more time to do another analysis. Yeah, so for example I can change here this to averaged FFT. This is here the acceleration channel. So, but in this case I have to change here the display. Let's say I want to see the data up to 600 Hertz. So because I change it here to FFT, the time domain is now here Hertz, the x-axis. So now I can go here from dB to linear, and here I say auto scale. So I'm not sure if I yeah. So now we see here the FFTs from channel number 1. And of course, if I go here to the display, I can say, okay, show me channel number 2. I can start. Here we see now the channel number 2. So let's assume I want to analyze this data with another program. For example, here this FFT spectra. So let's say then I click one time to this window, and here we see this function alternate G, that means for graphics. So I hit the keyboard, alternate and G, and now I can export this window in the CSV format to the hard drive, for example. So I think that's all for now, and I wish you good measurement results and have a pleasant time. Goodbye.